For my IQE this week, my question was, on a warm, cloudy day, a group of friends decided it was the perfect temperature to play a game of softball. When they arrived at the field, the temperature was roughly 25 degrees Celsius and there was no breeze, which made for the perfect playing conditions. The air had a thermal coefficient of 0.024 watts per meter Kelvin, and they brought a softball made of rubber, which has a thermal conductivity of 0.25 watts per meter Kelvin. The softball was approximately 9 inches in diameter and had a temperature of 20 degrees Celsius. So for my conceptual question, I asked if the overall resistance of the softball increases, decreases, or stays the same if they decided to play on a windy day. And the answer to that is the overall resistance would decrease because the air would no longer be natural convection. It would be forced convection, which increases the rate of heat transfer, thus decreasing the resistance to heat transfer. And for my calculation question, I asked to determine the rate of heat transfer. So I assumed that the softball is a sphere, the heat transfer is uniform, the thermal coefficient is constant, the conductivity is constant, and this is a one-dimensional problem. So first I converted my diameter to meters and found the radius. Then I found the resistance of the air, which is convection. So I did 1 over HA, which gave me 254.8 Kelvin per watts. And the resistance of the softball, I ended up doing just the conduction equation because it's not a hollow sphere. So I said that the length was the diameter itself and got that the resistance is 5.57 Kelvin per watts. So to find the rate of heat transfer, I did the temperature of the air minus the temperature of the softball over the sum of the resistances, and I got that the rate of heat transfer is 0.0193 watts.